Okay, so let us continue our discussion on relation. In the last class, we studied about two types of relation. One is reflexive and another one is symmetric. Okay, come to another relation that is called as antisymmetric relation. What is antisymmetric? So, say here how to define a relation. Whenever in exam, let's suppose come define antisymmetric relation or reflexive relation. So we'll do like this. Let R be a binary relation on A. What do you mean by this? R is a relation from A to A, that is called as on A. Then R is said to be antisymmetric relation if order pair A comma B in R implies BA is not in R unless A is equal to B. What is the meaning of this? If this is present in R, order pair A comma B, then B comma A will not be there in R. Only one uh, extra condition is that unless A is equal to B. Okay, what I mean by this A is equal to B, if I say A comma B and or you may say comma B comma A belongs to R, which implies A is equal to B, means both are the same element, that is called an antisymmetric relation. If both are the different element, then if A comma B belongs to R, then B comma A will not be in R. Come to an example. Let A be a set of positive integers. In A, there are positive integers are there, and R be a binary relation on A such that A order pair A comma B is in R if and only if A greater than equal to B. Okay, so is it a antisymmetric relation? Yes or no? See here. Let's suppose let A is equal to 2. Okay, then B is equal to, let's suppose, 1. We know that here 2 greater than equal to 1. This implies A greater than equal to B. I have taken value of A as 2, B is equal to 1. Okay, which implies order pair A comma B belongs to R. Okay, so if you may put the value of 2 here and B as like this. The value of A is 2 and value of B is 1, belongs to R. But can you say that 2 comma 1 belongs to R? Sorry, 1 comma 2. Can you say 1 comma 2 belongs to R? No, because 1 is not greater than equal to 2. So in R, what will the elements will be there for this particular example? 2 1, 3 1, 3 2, 4 1. It is a set of positive integers, it's written positive integers. So you consider only positive integers, then it will be 4 2, then 5 1, and so on. These are the elements of R. First element must be greater than the, sorry, in order pair, first element greater than the second. A greater than equal to is written, greater than equal to. But the question arises here, is 2 comma 2 belongs to R? Is 2 comma 2 belongs to R? Yes, because it's written as greater than equal to. What is written? Greater than equal to. So 2 is greater than equal to 2. So this is this condition. 2 comma 2 belongs to R. If I do the reverse of 2 comma 2, what will I get? Same 2 comma 2 belongs to R. So see here, this 2 comma 1 belongs to R, which implies 1 comma 2 doesn't belongs to R. Because 1 is not greater than equal to 2. With the first case 2 is greater than equal to 1, so it is belongs to R. The तार उल्टा नहीं जीवी, ये 1 को एठी लिखिली 2 को याडे आने देली, हैला ऑर्डर कर को चेंज कर देली तांकर ऑर्डर को, ले कोन हबो? इट इज नॉट बिलोंग्स टू आर. किंतु यदि ए एलिमेंट और ए एलिमेंट सेम थिबे, ले उल्टा कोले भी दे बिलोंग्स. that is I have written here. Okay, so that is the meaning of antisymmetric relation. In simple word, if a comma b belongs to R, then b comma a will not belongs to R. Only one condition is that যদি a or b are same, then reverse b belong kori pare. That is written here in the last condition. Come to transitive relation. Let A be a binary relation on A. R is said to be transitive if A comma C order pair is in R whenever both A comma B and B comma C are in R. Okay. In other words, I can say if A comma B comma this one, then B comma C belongs to R, which implies A comma C also belongs to R. This is called transitive relation. So here in this particular case, what do you remember? In this order pair, B is the second element. In this order pair, B is the first element. If you write it down in continuous manner, then B will come in between. Example: let A be a set of positive integers and R be a binary relation on A such that A comma B is in R if and only if A divides B. A divides B, like 2 divides 4. I have written divide is like this. 2 divides 4, which implies 2 comma 4 belongs to R. Let's suppose this relation is R here. This one R. So is this a transitive relation? Yes or no? So let's suppose I want to check whether it's a transitive relation or not. So I can say let A comma B belongs to R, which implies A divides B, which implies B is equal to, how can you write B? Like here in this case 2 divides 4, so how can you write 4 is equal to 2 into something, 2 into t something you can write. So similarly here B you can write A into t, you can write like this. Okay, next let B comma C belongs to R, which implies B divides C. Let me write it down as T1, which implies A case A comma B belongs to R लिखितली A divides B, तो हम ताको लिखलो B is equal to A T1. एटा बुझियला हमने लगा A example देखो 2 divides 4, so 4 can be written as 2 into 2 लिखि पारे मैं 2 जगह में T लिखि दे. Yeah, okay. So here B is equal to A T1, तो here C is equal to कौन लिखिबो B into T2. Okay, एटा हला equation 1, एटा हला equation 2. Which implies I can say what is the value of AT1, what is the value of B in the first equation? AT1, just put it here in 2. So C is equal to AT1 into A into AT1 into T2. Oh, eta likhibo from 1. From 1 रे मैं कौन कली substitute कली B जगह रे कौन लिखिली 88, which implies C is equal to कौन लिखिबो A into T1 into T2, which implies C is equal to A into T. लिखि देबो T is equal to T1 into T2. What is the meaning of this? Which implies A divides C. A case देखो 4 is equal to 2 into T लिखुथिलु. What is the meaning of this? 2 divides 4. I can write C is equal to A into T, means A divides C, which implies A comma C belongs to R. So it is a transitive relation. केमती देखो, how do you know this is a transitive relation? This one and this one belongs to R, which implies A comma C should belongs to R. So I proved it here. So this is a transitive relation. Very simple. मन करो मैं लिखिली गोटे एग्जांपल रियल लाइफ एग्जांपल लिखि टॉप रे लिखुछि 2 divides 8 correct or not yes or no 2 divides 8 as well as 8 divides 32 એટલે 2 divides 32 ହେବ କି નહીં ହେବ କି નહીં so this is a transitive relation so this division is a transitive relation any other example another example come to let A be a set of people A is set of people so this is a set here lot of peoples are there okay R be a binary relation on A so this is a relation binary relation कोठी अछि A रे such that order pair A comma B is in R if and only if A is an ancestor of B A is an ancestor of B ancestor means do you know so let's suppose this is a family tree in the family tree अछि ହେଲା what are these husband and wife let's suppose चला तांगर केतरा चिल्ड्रन थिबे let's suppose they are the children so let's suppose they are also got married so I'm just drawing the family tree मैंने गोटे चिल्ड्रन हेई पारे यानी को फर्दर तीनटा हेई पारे हैला so let's suppose this one is तांकर ना लिखि देली let's suppose A B C D E F हैला what is written A is an ancestor of B mane karo this person is A and this person is let's suppose small b okay so I can say A is an ancestor mane hala father grandfather grandfather or even grandmother and all hala so in the family tree A is an ancestor of B A ta upre asibo na tode asibo B re family tree re A ऊपर आसीबो सो हियर यू राइट A ऊपर आसला ताला B हैला मझरे गैप हेई पारे जनरेशन गैप देयर मे बी जनरेशन गैप so A comma B comma C like this belongs to R so here in this case A is an ancestor of B B is an ancestor of C that is like A is an ancestor of B and B is an ancestor of C so C will come here तोड़े आसीबे कि नहीं सो आमे एटी जानि पारबो कि नहीं A is an ancestor of C hobo that is AC belongs to R so this is a transitive relation first case रे आसलो ए केस रे A is an ancestor of B तो in the family tree B कोन होइबो तोड़े रहिबो A रो A टा ऊपर रहिला तापर पुणी कहिली B is an ancestor of C means B, C belongs to R so in the family tree B will be up and C will be down. A diagram ରୁ ଜଣା ପଡିଲା कि A is also an ancestor of C. So this is a transitive relation. Last example. Let A be a set of people and R be a binary relation on A such that A comma B order pair is in R if and only if A is a father of B. A is a father of B. Is it a transitive relation? A is a father of B. Is it a transitive relation? Try to analyze. Is it a transitive relation? Transitive relation means hala let's suppose A comma B B comma C belongs to R hala A is a father of B so this is the father कार father ote B ro this one is A what is written here B is the father of C so C is here does it mean that A is the father of C A is the grandfather of C okay so this is not a transitive relation but instead of this जदि मैं लिखी थांती ब्रदर लिखी थांती फादर जगह ब्रदर लिखी थांती नहीं थांता कि नहीं हेई थांता हैला A is the brother of B B is the brother of C it means A is the brother of C in case of हैला A is a brother of B and B is a brother of C it means A is a brother of C हैला यदि सिस्टर लिखी बेले होबो कि नहीं हैला एटा ए केस रे भी होबो किंतु सी हियर इट डजंट मीन कि जो लास्ट एलिमेंट এটা মেল भी ହେଇପାରେ ଫିମେଲ भी ହେଇପାରେ मेल भी ହେଇପାରେ ଫିମେଲ भी ହେଇପାରେ ହେଲା किंतु जदि मैं ब्रदर कहिबी ए इज ए ब्रदर ऑफ बी मींस ए इज ए मेल इट्स ए बॉय ए इज ए ब्रदर कहूछ हैला और बी टा कोन हबो बी इज आल्सो इज ए बॉय आई एम सेइंग ए इज ए ब्रदर ऑफ बी तापर एटी सेकंड आसला बी इज ए ब्रदर ऑफ सी ना सो बी बोथ आर मेल किंतु सी टा मेल है पारे फीमेल है सिमिलरली सिस्टर केस रे भी हैला जदि सिस्टर कहि बेले ए एंड बी बोथ आर गर्ल्स बट सी मे बी बॉय और गर्ल okay equivalence relation okay so I will continue this discussion in the next class equivalence relation okay so just I will tell the definition only a relation is said to be equivalence if it is reflexive in the previous class you studied reflexive symmetric and transitive the relation which is both sorry three reflexive symmetric and transitive then that relation is called as a equivalence relation okay so I will continue in the next class